So just yesterday, the earlier class, we have discussed that there are 4 register banks, right? Just going back, if we go back, then we'll go like this one, okay? So there are 4 register banks. Bank, just look into my copy, bank 0, bank 1, bank 2 and bank 3. Okay, so each of these each of the banks, register banks, they are having 8 registers from starting from R0, R1, R2 up to R7. Okay, so 8 registers are there. So just we look into this. That first, this address bank 0, in bank 0 R0 register is, the address is 00. So we can draw like just like this, a rectangular shape. Okay, so we will divide it among 4 parts, and again vertically 8 parts. Okay, so this is bank 0, this is bank 1, this is bank 2, and this is bank 3. Clear? So just like this, R0, R1, R2, R3, R4, R5, R6 and R7. Okay, just like this, every banks are having this R0 to R7 registers. Okay, and just in the figure, in the PPT, you can see that the bank 0 R0 register address is 00H. Okay, R1 is 01H, 02H is the address of R2 register. Like this way, this R7 register will have the value of 07H. Okay, just look into the PPT, you can see. Now again, the bank 0 ends at 07H. So bank 1 start at 08 and it will go up to 0FH. Again, bank 2 will start from 10H. Okay, and it will go up to 17H. Bank 3 will start at 18H and it will go up to 1FH. Clear? So each of the registers, this R0, R1, R2, R3, every registers are of 8-bit registers. Clear? Those all are 8-bit registers. So these 8-bit registers they are able to store 8-bit data. Okay, so just let me remind you that in this bank, these 4 banks, by default, this bank 0 is selected. By default means whenever you know about the restart of anything, whenever your mobile phone or computer starts for the first time, what happens? At first, the power supply goes to all of the hardware and peripherals present in the circuit, and then some platform that communicates within the hardwares, that is called the operating system. Okay, that program runs. First the program runs. So program includes like the processor needs to identify the printer. This processor needs to identify the mouse, identify the keyboard, identify the display, identify the power supply, everything, every hardwares and peripherals that are connected to the processing unit, that needs to be identified over using a software that is called the operating system. Okay, so this operating system at the starting of the any device, any processor device or any microcontroller device that are having that starts executing from the operating system. So after the operating system, I mean, when the operating system is booted, then the system is available to user. Clear? That means the user can start their processing or any operation or any program. Okay. So by default, at the when the microcontroller restarts, then every registers will be 00. Clear? So whenever a restart operation will be coming to the circuitry and all, okay. So when we will see that the when this kind of restart signal is given to the microcontroller, then the microcontroller content of all the registers will be reset to 00. Okay, just wait for some time. I'm sharing another one. Okay, is it visible now?
Yes, sir.
Okay, so just look into the this pin description of 8051. I'm just telling that it is a 40 pin IC, right? So this 40 pin IC, you can see this P1.0 to P1.7, these are port 1. Okay, I have shared a microcontroller architecture in the LMS platform. Okay, you can refer to that also, because that will be connected to, I mean, that is the block diagram of 8051 microcontroller. It will be asked in your internal examination also, and your internal examination is tentatively first internal, that is tentatively scheduled on during 9 to 11th of November. Okay, so this 40 pin, out of these 40 pins, there are 4 ports that are used for input and output. That IO ports are available as P1.0 to P1.7. This is port 1. Now pin number 9, it is restart. Just a minute. Somehow it is not showing the proper one. Now is it visible?
Yes, sir.
Okay, so you can see this is the 8051 microcontroller IC. Just look into this, that pin number 1 to 8, that is used for port 1, and the pin number 9 is used as the RST pin. So by giving an positive voltage to this pin number 9, we will see that how the restart operation is going on. And pin number 10 to pin number 17, these 8 pins are used for the port 3. And obviously, as the diagram implies, that port 3 is having another function. Okay, so another function means that means it is having some extra function, just like P3.0, that means the first pin of port 3, that is used for reception of serial data. And similarly, P3.1, that is the transmission of serial data. And INT0, INT1, that is nothing but the external interrupts. T0, T1 is the timer and counter operation that has been done by this P3.4 and P3.5. And write operation and read operation is done by pin number 16 and 17 respectively. So read and write operation is complementary to each other. And the pin number 18 and 19 is very important pin because the clock frequency is given into these two pins. And the operating, what is the operating frequency of 8051 microcontroller? Can anyone say?
12, say 12 megahertz. 12 megahertz.
Very good. That is, to be very exact, that is 11.0592 megahertz. Okay. So it is approximately 12 megahertz. Okay.
Or maybe, sir, 11.0529.
Sorry. Can you please repeat once?
11.0529 megahertz, sir.
Not 29, that is 92. 11.0592. Okay. So this,
Sorry, sir.
this kind of, it's okay. This kind of, I mean, this crystal frequency is to be given to the pin number 18 and 19. So pin number 18 and 19, obviously two pins are given. Why, sir? Because if any hardware crystal has been connected to this crystal pins, pin number 18 and 19, then what happens? Then the crystal is having two pins, two legs. So these two legs are to be connected with these two pins are to be connected with this pin number 18 and 19. Okay. So this pin number 18 and 19 is also having, we will see that how the crystal circuit is to be designed. Then we will tell you that what is the significance of 18 and 19. We'll come to that, the circuitry. So, and pin number 20, look at pin number 20 and pin number 40, that is ground and VCC respectively. So this is the typical configuration or the pin configuration of any IC, any integrated circuits. So starting from 20, pin number 21 to 28, these 8 pins are used for the port 2. And pin number 29, PSEN, we'll come to that program store enable. And pin number 30, ALE bar oblique PROG, that means address latch enable, complement or PROG. What is the function? We'll come to that. That pin number 31, that is external access EA bar or VPP. These 3 pins, this PSEN, that is pin number 29, 30 and 31, we'll come to that. What is the function in detail later on. And after that, pin number 32 to 39, these 8 pins are used as a port 0. So there are some extra functions that is mentioned in the bracket. Just see that port 0 and port 2 are used for another operation. This port 0 will be used as the address data multiplexed. Okay. But in case of port 2, as we have discussed, that these 8 pins, port 2 8 pins are used for the address bus, higher order address bus. Clear? Just see that AD0 to AD7, that means the lower order address and the data are multiplexed. But in case of higher order address, there are no data multiplexed because 8051 is the 8-bit microcontroller. So the data bus must be 8-bit wide. Is it clear? Any questions on this?
No, sir.
Okay, so we'll go forward. Just look into this, that as per the pin diagram, out of 40 pins, whatever we have discussed, 32 pins. Why 32 pins, sir? Because port 0, that is 8 pins. Port 1 has 8 pins. Port 2, 8 pins. Port 3, 8 pins. So how many total? That is 32 pins. Clear? So these 32 pins, apart from these 32 pins, there are 8 pins remaining. So what are the 8 pins? Just look into this. One is VCC, number 2 is ground, number 3 is external, that means crystal 1 and crystal 2, number 3 and number 4, number 5 is RST, number 6 is EA bar oblique VPP, ALE, number 7 is ALE oblique PROG bar, and PSEN bar, number 8. Okay, now VCC and ground, you know the configuration or the operation that is done by the ground and the VCC, because this operates in the range of 0 to 5 volts. Okay, so obviously in the VCC there should be 5 volt 5 volt should be given to operate it in a clear way. And external 1 and external 2, that is used for the crystal or the external clock. So RST, that RST means pin number 9. Pin number 9 is it is an input pin, and it is also active high. That means whenever a high signal is given to this pin is activated. Okay, so how this RST pin operates, that will be discussed with a circuit also. So this EA, that means external access. Okay, as we have discussed that the total memory length, the total addressable memory range is 64 kilobytes in the 8051 microcontroller. So we can also tell that the total addressable area is having 64 kilobytes of ROM, that needs a ROM, but only 4 kilobytes of ROM is available in the on chip. Okay, so rest of the, we have discussed it earlier also, that rest of the 60 kilobytes of the ROM can be connected externally. So whenever it is connected externally, then this EA bar oblique VPP will be needed. Clear? So whenever accessing this external memory, this EA oblique VPP, EA bar oblique VPP, that is pin number 31, must be connected to ground. Okay, otherwise it should be connected. I mean, you can also you can also omit this. Okay, the VPP signal is used where the time used at the time of EEPROM programming. That means whenever some program has you have written some program in the simulator and in the hex file, and subsequently you are writing the program onto this, just like the writing on a CD. Okay, you are burning the CD. So similarly, whenever burning this microcontroller, then 21 volt supply is to be given it through this pin. And what is ALE? What is the function of ALE oblique PROG bar? That ALE pin 30, pin number 30, that stands for address latch enable. Now, the general function of address latch enable is like this, that whenever any address data is multiplexed, then to demultiplex these two, from address data multiplex, if we need the address and data separately, then we need to use ALE signal. Okay, so again this ALE signal enables this latch IC, we'll see. Okay, and PROG bar is used at the time of EEPROM programming. Okay, and a 5 millisecond pulse should be given, 50 millisecond pulse should be given through the ground during the EEPROM programming. So during the EEPROM programming, this PROG bar and VPP, these two pins are very important. Okay, and pin number 29, that stands for the program store enable, and this is an output pin and connected to the external ROM. Okay, we'll come to that, what is the function of this. Now coming to the crystal oscillator. So up to this, any questions?
Sir, the BPP is where we are giving the power supply. So here it is written 21 volts, but our microcontroller works on the 0 to 5 volts. Sir, why it is written 21 volt there?
Yes, but please remember that at the time of EPROM programming, we need to use some microcontroller program burner. Okay, so during this program burning operation, a very high pulse is to be given to this pin only, and this pin is designed in such a way that this, I mean, giving a high pulse to this pin doesn't affect the microcontroller. But whenever the operating frequency, because this is not the operating voltage, okay, this is a voltage that is to be given during only the time of program burning. Clear? Because suppose using a microcontroller for your TV remote control, so there must be some program should be written, and that program is to be incorporated within this 8051 IC. So how that can be done? So by using a program burner. Okay, understood?
Yes, sir.
Okay, so we are discussing that how the program, I mean, how the oscillator circuit works. Okay, how the oscillator circuit works. Now just see that external 2 and external 1, that is nothing but pin number 18 and pin number 19, that is connected to this particular crystal IC. Okay, so these crystal IC is having two legs as we have discussed, and these two legs are connected with the ground by connecting these two capacitors. So these two capacitors are used for the stabilization of the output. So what is what is the function of this capacitor that is used for the stabilization of the crystal output? Clear? Just do this now. Okay, done everyone. So I'm stopping this.
Okay, sir.
just see, I'm just resuming just a couple of points that this capacitors are, I mean, by experiment, it has been found that if we use this 30 picofarad capacitor in parallel with these two, I mean, in parallel with the crystal oscillator, then the output will be mostly stable. But in case of practical circuit designing, it has been found that there are no presence of this 30 picofarad capacitor. So the nearest one to this 30 picofarad capacitor is 33 picofarad. Okay. So while circuit designing, you need to have 33 picofarad capacitor. Okay. We cannot found this 30 picofarads. Clear? Now again, we can also omit this crystal 2 pin by just if we can generate the clock frequency externally and it is to be given to crystal 1, then this this crystal 2 pin, external 2 pin is of no use. Okay, so that is connected as, I mean, that is written as NC, that means not connected. Okay, so probably this section is done, and we'll start from the reset circuit in the next class. Okay, thank you.